okay, we have talked about molar mass. Okay, there is this thing called molar volume. Okay, so this molar volume is only for gases and concentration is only for aqueous state. Okay, so let's take a look. So remember this guy, Mr. Avogadro? Alright, so he was the one who found out and discovered about the 6 times 10 to the power of 23. Okay, so he discovered another thing. So he discovered that for gases, when they're in gaseous state, they behave in the same way. So what do I mean by this? Okay, he realized that 1 mole of any gas, it can be hydrogen gas, oxygen gas, they contains the same volume. And this volume is always the same, which is 24 dm cube. Okay, so I repeat, Mr. Avogadro, he discovered one thing. He realized that gases, when they're in gaseous state, right, they all occupy the same volume. Okay, so they all occupy the same volume, which is 24 dm cube. So 1 dm cube is 1000 dm cube. Okay, and this is only for room temperature and pressure. So all our questions, okay, by default, they are room temperature, which is 25 degrees Celsius, and atmospheric pressure, which is 1 atm. Okay, so molar volume means the volume of any gas for 1 mole. Okay, so which also means equal volume means same number of moles. Okay, but of course, different gases, they have different mass. Okay, so what do I mean by this? Okay, we take a look at this example here. All right, 1 mole of oxygen is 24. 1 mole, because that's what Mr. Avogadro said. 1 mole is 24. So if I have 2 moles of oxygen, it's 48. Okay, so 1 mole of oxygen is 32 grams. Okay, let's take a look at carbon dioxide. 1 mole of carbon dioxide, 1 mole, according to Mr. Avogadro, 1 mole is 24. 2 moles of carbon dioxide gas, 2 moles, I multiply by 2, which is 48. Hydrogen, 1 mole of hydrogen gas, 1 mole is always 24. And if I give you 48 dm cube of hydrogen, 48 dm cube, 1 mole is 24. 48 dm cube is how many moles? You work backwards, it is 2 moles. Okay, so I want you to take a look at the 1 mole first. Okay, for 1 mole of oxygen is 24. 1 mole of carbon dioxide is 24. 1 mole of hydrogen is 24. Agree? However, 1 mole of oxygen is 32 grams. 1 mole of carbon dioxide is 44 grams. 1 mole of hydrogen is 2 grams. They all have the same volume, but they all have different masses. So, equal volume of gases, they have same number of moles but different masses. Okay, as we can see from the table. Alright, so what do you notice about the relationship between volume and number of moles? So if you take a look at this, as my number of moles increases from 1 to 2, what happened to the volume? It will also increase. As my volume increases from 24 to 48, what do you notice about the number of moles? It will also increase. Okay, so the relationship between these two is quite straightforward. They are directly proportional. Okay, they are directly proportional. I increase 1 mole. If I increase 1 mole, I increase 24 dm cube. If I increase 24 dm cube, I will increase 1 mole. Vice versa. Okay, so how do I calculate the number of moles of a gas? So actually, okay, same thing. You don't really need to memorize the formula. As long as you know 1 mole is 24. As long as you know 1 mole is 24, okay, whichever number that I change, you should be able to get it. Okay, so fill in the blanks inside your notes. The number of moles, okay, is equivalent to the volume of gas divided by 24 dm cube. This 24 only for gas. I repeat, this 24 is only for gases. Okay, likewise, okay, you ask yourself this. Alright, if I'm given 72 dm cube, if I'm given 72 dm cube, how many moles? Okay, you will tell me 3. And then I ask you, hey, how you get 3? Because you tell me 72 divide by 24. Okay, because 1 mole is 24, 72 is 3 times of this is 3 moles. Okay, take note, 1 dm cube is 1000. So it's either you use 24 dm cube or you use 24,000 cm cube. Okay, so if you use 24,000 cm cube, your volume of gas will be in cm cube. So the units must be the same. Cannot be 1 cm cube, then 1 dm cube. Okay, so if you want to use dm cube, everything dm cube. If you want to use cm cube, everything cm cube. Okay, so let's try page 13 of your notes. Okay, question 1a. You are given 0.5 moles of hydrogen. Okay, the question asks, so what's the volume? Okay, we know that 1 mole is 24. Okay, we know that 1 mole is 24. So if I have 0.5, all I need to do is 0.5 times 24, and I'll get 12. Leave your answer in 3 SF. Okay, now what if it's 3 moles of carbon monoxide? Without showing you the answer, can you pause the video and start to calculate? So 1 mole is 24, 3 moles is 72 em cube. 3 SF. Okay, what about if I give you volume? Now I ask you to calculate the number of moles. Okay, so for volume wise, okay, you know that 24 is 1 mole. So 50 dm cube is definitely more than 1 mole. 50 divided by 24, you get about 2.08. Okay, so the number of moles is 2.08 mol. Okay, the unit is mol. Fill it in. Alright, so now I change. Instead of dm cube, I use cm cube. cm cube. Okay, so I know that 1000 cm cube is 1 dm cube. So I can convert. Okay, so I convert to form this. 4 divided by 24, I'll get 0.167. If you don't want to convert, you can use 4,000 divided by 24,000. Both, you will get the same answer. Okay, so moving on, let's try. Balloons of the same volume contains the same number of particles. True or false? So same volume, for example, 24. 24 dm cube means number of moles is 1. If both balloons contain 1 mole is how many particles? 6 times 10 to the power of 23. Okay, so you should be able to get the same number. Answer is true. Okay, so according to Mr. Avogadro, he said this. Equal volume means same number of moles. Same number of moles means same number of particles. Because if you recall, mole is a quantity. So it's like pair, it's like a dozen. Okay, a dozen of eggs and a dozen of apples, they all means 12. The unit 12, so it's the same thing. Okay, now balloons of the same mass contain the same number of particles. True or false? Okay, you need to ask yourself again. Balloons of the same mass. So you ask yourself, 12 grams of hydrogen versus 12 grams of oxygen. Is it the same? Answer is false. Okay, so I give you one example. Yeah. If I have balloon of the same number of particles, for example, 6 times 10 to the power of 23 is 1 mole. 1 mole of helium gas is 2 grams. Because Ar is 2 grams, right? 1 mole of argon, is 40 grams. So, do they have the same mass? They don't have. Okay, same number of particles does not equate to same mass. Same mass does not equate to same number of particles. Okay, we combine all the equations together in your notes, page 14. This is the first ever equation that we've learned. Mass over molar mass, find number of moles. The second one that we have learned so far is about the gas. Okay, now take note, this equation here is for all substances. Solid, liquid, gas. But this one is only for gas. Okay, so I want you all to take note and circle this part. Okay, so if I want to combine the equation, number of moles equals to mass over molar mass equals to volume over 24 dm cube. And this is only for gas, take note. Okay, so summary, page 14. Equal volume of gas under the same condition, which is room temperature, they contain the same number of particles and therefore same number of moles. Volume of gas occupied by 1 mole, okay, is molar volume. Molar volume means volume by 1 mole of gas. Molar mass means mass of 1 mole of substance. Alright, so they are both talking about 1 mole. Okay, so I want you to try question 1 to 2 on page 14. So pause the video and do your work. So for question 1a, you are given sulfur trioxide, okay, 6 dm cube, and from here you are supposed to calculate the number of moles. Okay, so the formula used here is volume of gas divided by 24. Okay, so 6 dm cubed. Okay, you have 6 divided by 24 is 0.250. Okay, so to 3SF, the number of moles is 0.250. So if you don't want to write number of moles, you don't want to write these three words, right? You can just write the word N, and then you can write SO3, something like this. Okay, then let's take a look at part B. So same question, you're given 6 dm cubed. Just that instead of finding the number of moles, they ask you to find mass. So if I use from part A, okay, I get this. Okay, now I need to find one more step. I need to do one more step to get the mass. So we learned that 1 mole of SO3, okay, 1 mole of SO3 is 32 plus 3 times 16. So this is the molar mass. Okay, we call the first equation. 1 mole of SO3 is this, 1 mole. Now you are given 0.25 moles. Okay, so 0.25 times this number, you will get 20. So 6 dm cubed. First of all, you need to calculate the number of moles before you can calculate the mass. Okay, so this is 3SF. Okay, so if I were to look back at the equation, for example, this one here, okay, you notice that this is the first one that we learned, right? For all substances, and this one is for gas. The common thing about these two equations is the number of moles. So I will always find the number of moles first before I find something else. Okay, so let's go back. Alright, so question 2. Question 2, you're given this unknown gas. You don't know what is it. Okay, you have 100 grams. Okay, you're supposed to find out. And you are given this huge value. Okay, 600,000 cm cubed. So what I will do is I will find the number of moles. Always find the number of moles. How to find? Volume divided by molar volume. In this case, it's cm cubed. So I divide by 24,000 cm cubed. Use the one with the same unit. So from here, I calculated, okay, this hot air balloon actually contains 25 moles from this 600,000 cm cubed. Okay, so I use this formula, mass over molar mass, to find the number of moles. Now, do I know what is this gas X? I don't know. But I know the mass. Mass is 100. Do I know the number of moles? Yes, from the previous step. Okay, so I calculate 100 divided by 25 is 4 gram per mole. Okay, so the question is, what is this gas X? So from this question, they tell you molar mass. 1 mole of this gas is 4 gram. So you look at your periodic table, molar mass is the same as your AR. Okay, so look at your periodic table, which gas has 4 grams? Okay, it cannot be hydrogen, because hydrogen is H2, is 2 grams. So the only gas that's available that can be this is your helium. Okay, so this is how you use the two equations together. Okay, the one with mass over molar mass and the one with volume over molar volume. Okay, so that's why we combine these two equations. They can help to calculate number of moles, and then they can use to find from one value to another. Okay, so this is molar volume of gases. Okay, we're going to end soon with the last part, which is concentration. Alright, so let's take a look at this part here, concentration. Okay, so from this picture, I have 2 cups of water, same volume of water, and on the left, I add 1 spoon of Milo powder. Okay, on the right, I add 3 spoons of Milo powder, which is more concentrated. I'm sure you will tell me the one on the right, right? Why? Because more spoons. More spoons of Milo powder added. And then the volume of water is the same. Okay, so what is exactly concentration? Concentration is the amount, okay, the amount here, amount is the one in the spoon, dissolved in a given volume of water. Now, this volume is different from the volume earlier on. This volume is talking about solution. The previous volume, we are always talking about gas. Okay? Now, ask yourself, in this case, concentration. What is the state symbol for concentration? Concentration here, we are always talking about something dissolved in water. Okay, something dissolved in water. So this is aqueous state. Okay, write down. This part is only for aqueous state. Okay, so write it down inside your notes. Okay, so concentration can be 2 ways. One is mass over volume. Okay, the amount, okay, the mass they are dissolved in a fixed volume. Okay, for example, in this case, every 1 dm cube of solution, I add 10 grams of sugar, for example. Every 1 dm cube of solution, I add 10 grams of Milo powder. Or I can also use number of moles. For example, every 1 dm cube of solution, I added 2 moles or 2 units of Milo powder, 2 units of sugar. Okay, so both are referring to the same thing, just that the units are different. One is about mass, okay, the mass you dissolve. The other one is the amount, the number of moles. Okay, so let's see, right? So the formula for this is G divided by dm cube, right? So grams divided by dm cube. Okay, mass refers to grams. Volume here is the amount, the volume of water. Okay, and this is the unit. So grams divided by dm cube, you get this. So if you ask me, do I need to memorize? I memorize this unit can already. Take a look, I memorize this unit, grams per dm cube, which means gram divided by dm cube. Likewise, same thing, I remember this, mole divided by dm cube. Mole divided by dm cube means mole over volume of solution in dm cube. How to convert between these two, okay, is to use this equation. Okay, actually both are referring to the same thing, just that one is in gram, one is in mole. So all you need to do, you convert G to mol. How to convert? G, you want to convert to mol, right? So take a look at this equation. G, you want to convert to here. G to N. So what you do is G divided by molar mass, you get number of moles. Okay, right? So this is the formula to convert gram per dm cube to mole per dm cube. Now, if you cannot remember this, it's actually fine. Don't have to worry. Okay, you can choose to do the longer way. Okay, then as you do, you realize that actually it's the same thing. Okay, so let's try some questions. Okay, and you can see how to apply them. Okay, so the first example. Okay, you are given 10 grams of sodium hydroxide and you dissolve it in 200 cm cube. So what they want you to do is calculate concentration in grams per dm cube. So grams, you're given in grams. Then they want in dm cube. So of course, I need to convert cm cube to dm cube. Okay, so 1 dm cube is 1000. So 200 is 0.2. Okay, so the conversion is the same, okay, between dm cube and cm cube. Alright, okay. So concentration is gram per dm cube. I need to use gram, okay, which is 10 gram here, divided by dm cube. Okay, so 10 gram divided by 0.2 dm cube. The answer is this, 3SF, 50.0, 3SF. Okay, so this is answer for part 1. Now part 2, okay. If I use the normal method, the long method, I want to calculate mole per dm cube. See this, I want to calculate mole. So am I given mole here? No, I'm not given mole. So I use the method that we learned at the start. First of all, always calculate the molar mass. Molar mass is NaOH. 23 plus 16 plus 1. 40 gram per mole. Okay, so this means 1 mole, 1 unit of NaOH is 40 gram. You are given 10 gram. So 10 gram of sodium hydroxide is actually only 0.250 mole. Okay, so I repeat, 1 mole is 40 gram, 10 gram is 0.250 mole. Okay, so you're actually given 0.250 mole of sodium hydroxide. And you need to dissolve in 0.2 dm cube. So what you do in method 1 is number of moles, divide by the volume, which is this. Okay, and your concentration is 1.25 mole per dm cube. So this is the long method, the first method. Okay, however, if you are able to understand this equation, how to convert G to mol, is actually faster. And that is method 2. Okay, so actually, part A, you have this, right? Part A. What you need to do is convert G to mol. G to mol. So what to do? You want to convert G to mol, right? Can you see this? This is my cursor, G to mol. You want to convert G to mol. What you do is 50 grams divide by the molar mass. Okay, you take a look at this equation here, G dm cube here, from here. If I divide by molar mass, I cancel away the gram. I cancel. Okay, I'm left with this unit here. Okay, so I cancel here. And then I have this part left. Okay, I have this part left. Okay, so if you do your math, right, this mol to the power of -1, if I divide by it, I will be able to change it to mole per dm cube. So this dm cube is here. This mole to the power of negative 1 will go up. Okay, so if I use 50, okay, 50 from part A, divide by molar mass, cancel away the G, I'm able to get mole per dm cube. So this is a faster way. So actually I skip this part here. Skip this additional step and straight away go to this part. Alright, so this is what we call the faster method. So if you understand method 2, just do method 2. If you understand method 1 better to you, is easier, okay, just go ahead and do method 1. Both also can get the same answer. Okay, so continue the remaining questions. Okay, without looking at the answer, try it yourself. Okay, so likewise, okay, I convert to dm cube first. I'm given 10 gram. So this 10 gram divide by the volume. This volume is the volume of solution. It's not your molar volume. Molar volume is only for gas. Okay, so mass 10 gram divided by volume is 40 gram per dm cube, 3 SF. Okay, part B. Method 1, do the long way, find the molar mass MR, which is 74.5. Mass over molar mass, I get this. Mass over molar mass. And then concentration is number of moles divided by volume. Okay, so this is the longer method. Method 2, I use gram over dm cube. Straight away, I divide by the molar mass. Okay, straight away, I divide by molar mass. Okay, and then I will get the concentration. Actually, class, if you notice, eventually method 1, I'm also dividing by 74.5. Okay, do you see this? I'm dividing by 74.5. Same, I also divide by 74.5. Okay, so both methods also need to divide by molar mass. Just that this part here, okay, you go straight from 40, divide by here. Okay, question 2. Okay, you are given this concentration now. You're given this volume. So now it's working backwards. Just now I asked you to find concentration. Now I give you concentration. You need to find the number of moles. Okay, so let's take a look at part A. Okay, you are given this concentration. So concentration, you're given this volume. I always convert volume to the same unit. So what I do here, 600 divided by 1000, I will get 0.6 dm cube. Okay, so volume times the concentration. So dm cube. So actually the unit here for this portion here is dm cube. Okay? So if I use the unit to calculate, I cancel this, I get the unit mole. Okay, so this is how you get part A. Okay, then for part B, they ask for mass. You have 0.9 moles of NaOH, 0.9 moles. Okay, you want to find mass, right? You calculate by multiplying it with the molar mass. So leave your answer in 3 SF. So you get 36.0 grams. Okay, question 3. Let's take a look. So in this case, you are given 3.4 grams of barium hydroxide and you are to prepare a concentration of 0.1 mole per dm cube. So now instead of giving you the mass and then the volume, they are asking you to calculate the volume now. Okay, so that you want to prepare this concentration. So it's the same steps, okay, same formula. You need to calculate the mole because here you are given mole per dm cube, right? So you need to convert this 3.4 gram to mole first. So how to convert? Always use mass over molar mass. So to do this correctly, of course, you need to know the formula of barium hydroxide. If you don't know the formula of barium hydroxide, you will do it wrongly. Okay, so formula writing is important. Okay, mass over molar mass. Okay, you get the formula right to calculate the molar mass and you get 0.01988 moles. Okay, and then from here, you are given 0.1 mole per dm cube. So take a look at this formula. Concentration is mole per dm cube. Mole divided by dm cube. So you have this concentration, which is 0.1. Okay, you have this number of moles, which is 0.01988. Okay, so what you need to do is you convert 0.01988 divide by concentration. You will get about 0.199 dm cube. So the volume you need to prepare to get this concentration is 0.199 dm cube. Okay? Okay, now let's move on to the last question. So in this question, you are given this solution, 500 cm cube. Okay, you are to prepare to this concentration called 0.4 mole per dm cube. So this is a very real situation where, for example, the chemicals that you use in lab, Okay, so the lab tech will prepare maybe 1 mole per dm cube concentration of acids and alkaline. And then she say, okay, 40 students, I need to prepare 4 liter. So she will start to calculate, okay, this volume, this concentration, how much of the solid potassium hydroxide I need to dissolve, so have to weigh. So these are the calculations, and these are the things that you see, okay, whatever that we learned so far, okay, it can be applied to here. Okay, so first of all, I have 0.4 mole per dm cube. I need to prepare 500 cm cube. So I will need to calculate the number of moles first. Okay, so if you take a look at this equation, I use the concentration equation. Okay, mole per dm cube multiplied by dm cube. So I cancel away the dm cube unit. You realize that, oh, I managed to get number of moles, which is 0.2. Okay, so I need 0.2 moles of KOH. I need this number of moles. So what is the mass of 0.2? Okay, so I will need to ask myself again, okay, what is the mass of potassium hydroxide for 1 mole? Okay, which is molar mass. Okay, so to calculate molar mass, I will need to know the combinations of AR of all these, K plus O plus H. Okay, so total is 56 for 1 mole, 56 grams for 1 mole. So 0.2 mole will be 0.2 times 56. Okay, so the mass that I need is 11.2 grams. Okay, I need 11.2 grams to prepare, dissolve in this amount of solution to get this concentration. Okay, so this is how we do it, right? So yes, we have finally completed the mole. Okay, so I hope at this point of time you know why is mole so important. Okay, because mole gives us a certain quantity, okay, that allows us to calculate the mass. So you are very special. Okay, not sure whether you are aware, okay, there is actually this sauce that is used in Mexican cooking. So it's also called mole or mole. Alright, so mole does not just mean the mole on your body, does not just mean the mole, the animal, does not just mean chemistry, it also relates to food. Okay, and then with this, we're going to move on to the next topic, which is called chemical calculations. Alright, so far we have talked about mass of one substance. Okay, what about in the reaction? If I want to react A and B, how much of A, how much of B? I need to calculate the ratio. Okay, so that is for the next part. Alright, so hope everything is good. See you. Bye bye.